Good evening friends, study with the Pala Engineering and General Geology Parvin Singh book। तो आज से हमारा नया चैप्टर 17 चालू हो रहा है जिसका नेम है इंजीनियरिंग प्रॉपर्टी ऑफ रॉक। तो इंजीनियरिंग प्रॉपर्टी ऑफ रॉक में अपना इंट्रोडक्शन देंगे। इसमें रॉक एज मटेरियल्स फॉर कंस्ट्रक्शन, बिल्डिंग स्टोन्स, रोड मटेरियल्स एंड द रॉक एज साइट फॉर कंस्ट्रक्शन, इंट्रोडक्शन, लेबोरेटरी टेस्टिंग ऑफ रॉक। भाई लैब में भी टेस्ट किया जाता है कि हम जब इंजीनियरिंग प्रॉपर्टी यानी कि कोई कंस्ट्रक्शन हो रहा है, डैम बना रहे हैं, रिजर्वायर टाइप के, रोड बना रहे हैं, तो उसमें जो रॉक किया, जो मटेरियल इस्तेमाल किया जा रहा है, उसकी प्रॉपर्टी क्या है, वो कितना स्ट्रांग है, कितना वीक है, ये चीज भी देखी जाती है। तो इंट्रोडक्शन, अ सिविल इंजीनियर हैज टू डील मोस्टली with the soils, rock, timber, steel and concrete. In a great majority of civil engineering projects, soil and rocks forms the sites of construction directly. So directly, examples, construction is made on them or through them, and so whereas engineering property of soil are studied under soil mechanics. Those of rocks fall till date in the domains of engineering, geology. The new branch of rock mechanics has developed at such a fast pace during last few years that it has already become a compulsory part of advanced civil engineering practice. Rock mechanics deals essentially with the behavior of rocks under applied force field in natural as well as in laboratory conditions. Engineering property of rock is rather a generalized term. It might be understood to include discussions on and practical determination of all such properties of rocks that are relevant to engineering applications of these materials, either after their extraction from their natural place of occurrence or without extraction. Example, in their stew condition. The first set would then include all those properties for which rock specimens must be tested in the laboratories for selection as materials of construction. For example, as building stones, road stones or aggregates for concrete making. The second set of properties would include the quality of natural beds or rocks mass that would determine its suitability or otherwise as sites for a proposed engineering project. Obviously, in both cases, the economy and safety of an engineering project are greatly dependent upon the proper understandings of these properties. It is therefore desirable to discuss the engineering properties of rocks under two broad headings: rocks as materials of construction and rocks as sites for constructions. Parts A is rocks as materials for constructions. Building stones. Introduction. Building stones may be defined as sound rocks that can be safely used in some situation in the construction as a massive dressed or undressed unit. Granite and marbles used in the forms of finely dressed block or slabs or columns in monumental or costly buildings are good building stone. And similarly, sandstones are limestones used in forts, retaining walls and boundaries walls, and also as a block in stones house and bungalow. They are typical building stones. Slates used in many areas as roofing materials for ordinary construction and in pavement also fall in the category of building stone. Stone masonry is an engineering art that is preserved in many historical buildings in all parts of the world. This skill is still used though on a lesser scale because of the advent of concrete in the construction of common residential houses and palatial buildings in many places. The Taj Mahal at Agra, the Red Fort in Delhi, and temples of Jagannath Puris are some of the best known stones marvel of India. Such example may be compiled from all countries of the world, and the numbers may run into many hundreds. Properties. What physical, structural, and other properties rocks should possess to be recommended as building stones will depend upon the types of construction and the situation within that particular construction where the stone is intended to be used. Thus, a stone to be used in the floorings for a buildings need not possess all those qualities that are must for stones to be used in the foundations and load-bearing walls. Similarly, stones required for making retaining walls need not have all the properties required for that intended to be used in facing walls. It is therefore considered convenient to discuss various qualities governing the selections of building stones under 3 subheadings: and strength, characteristics, and geological character and general character. Strength character. Characteristic stones, like also the solid fields, when subjected to load beyond their strength, and the failures takes place under compressive tension and shear forces at different values. It is, however, the unconfined compressive strength which is taken as the most important index property of a stone. Compressive strength. It is also sometimes referred as a crushing strength of a stone, and many be defined as the maximum force expressed per unit area which a stone's caves withstand without rupturing. Any force applied beyond the compressive strength and will cause a failure or rupture of the stones. And mathematically, an axial compressive strength is expressed by simple relations. Operation C is equal to P by A. तो C is 0 is equal to compressive strength या unit area कहते हैं, और P load at failure and A area of cross section of stone under P. Okay, pressure. Load at failure. Okay, practical determinations of unconformity compressive strength of a building stones is carried out in a well-equipped civil engineering laboratory. Representative test specimen of standard shape, either cups of 5 centimeters sides or cylinders of length diameters ratios of 2 to 2.5 prepare carefully are loaded gradually at one at a time on the base plate of UTM. Any universal testing machines, the loading is continued till the first crack appears in the test specimens, indicating the beginnings of the failure. Any further loading will crush the specimen. So the load at a failure P divided by the area of when the compressive strength is tested by a method providing lateral supports as by keeping the specimens in a special cells, triaxial cells filled with the liquid under pressure. So the value obtained is called confined or triaxial compressive strength. It is, however, the unconfined or uniaxial compressive strength that is generally taken into considerations in civil engineering constructions with the stone. The compressive strength of a rock depends on a number of factors such as its mode of formations, its composition, texture and structure, its moisture content and extent of weathering. It has already suffered in igneous rocks being crystalline in characters, compact and interlocking in texture and uniforms in structure, possesses very high compressive strength and compared to sedimentary and metamorphic rock. In the latter two groups, in abundance of planes of weakness such as bedding planes, foliations, schistosities and cleavage greatly affect the compressive strength of the respective rocks in magnitudes and directions. Talking about direction, sandstones may show a very low compressive strength when loaded parallel to bedding planes, when that the same stone is loaded perpendicular to the same structure and except for some varieties of massive sandstones, limestones, quartzite, marbles, and gneisses, most of the sedimentary and metamorphic rocks are inherently weak in crushing strength. The strength values as obtained from laboratory testings may also so considerable variations with respect to the same rocks depending upon the size of the test specimens, the smoothness of the contact place of the test specimens, the road of loading, and the duration of load. It is therefore simply implied that all the laboratory tests are carried out strictly in accordance with the standard codes as issued by the specified authorities of the country. The Bureau of Indian Standards codes should be referred in India's in designing constructions with stones. Compressive strength of many types of buildings stone is generally much higher than the loads they are often stopped to withstand in ordinary types of buildings construction. Follows the values give a general idea of the compressive strength range for some common building stone. A uniaxial compressive strength and range of some rocks kilogram per centimeter cube. Igneous, sedimentary, metamorphic. Granite 1000-2500, dolerite 1500 to 3500, basalt 1500 to 3500, sandstone 200 to 2000, limestone 200 to 2000, cells 50 to 150, metamorphic rock में gneisses 500 to 2500, quartzite 1500 to 3000, और marbles है 7000 to 2000. So during the last few years, thousands of tests have been carried out on rock strength in different parts of the world. An attempt has been made by Deere and Millers to classify rocks on the basis of a compressive strength range. Engineering classification of a rock. So types and description. Uniaxial compressive strength kilogram per centimeter. A is very high strength, more than 2240, and B high strength 1120 to 2240. C medium strength 560 to 1120, and D low strength 280 to 560. E is very low strength, less than 280 kilogram per centimeter cube. Not a cube, sorry, square. So please make a diagrams with labeling और प्रैक्टिस करिएगा. ये लोडिंग प्लेट दिखा रहा है, स्टोन सैंपल है, बेस प्लेट है, लिक्विड अंडर प्रेशर बेस है, स्टोन है, स्पेसिमेन है, पिस्टन है. पिस्टन वही प्रेशर के लिए यूज किया जाता है, और सेल बॉडी, रबर मेम्ब्रेन्स एंड बेस. ठीक है. Thank you. Please support it.